20th, that's a 20. So September 20th, 2011. We're doing lesson 1.3. We're just going to do the other half of it. And then we're going to review some of the concepts because we have a quiz tomorrow. So, just to recap, if you guys remember, we had CAST, our caste system. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So, we're specifically working on angles that fall in quadrant 1 and quadrant 2. So we're working on acute and obtuse angles. Acute angles fall in quadrant 1 and obtuse in quadrant 2. What we're going to be doing today is I'm going to give you coordinates, and you guys are going to be setting up right angle triangles and solving for either the acute or the obtuse angle. So we're going to say that this is, actually we'll number this graph. Okay, so we have our graph, and I'm going to be looking at coordinate 5, 4. Okay, so we have our coordinate 5, 4. I need to plot this on a graph, and I want to find what acute angle this coordinate will make. So what I mean by that, first of all, is our 5 represents our x coordinate, and 4 is our y, and this is our y-axis and our x. We're going to go plot this. So if our x is 5, I go over to 5 on the x-axis, and y is 4, I go up to 4. That is our point. So this is our point on the graph. Now what I need to do is I need to make a right angle triangle from that. To make any right angle triangle in the obtuse or acute, so in quadrant 1 or 2, we start from the origin and we draw a line to our coordinate. Okay? This line will be the hypotenuse of the right angle triangle. So from the origin to the coordinate will always be our hypotenuse. From the point, we're just going to draw straight down to our line. And then we've created a right angle triangle. Okay? Now I want us to find the acute angle, which means I want us to find the angle at the origin, the one touching the origin. And if you guys remember, the origin is 0, 0. That's what I'm talking about. So I need to find this coordinate. Now, on the triangle, it doesn't look like I have any measurements, but I actually do. It says x is 5 and y is 4. That tells me that this part of the triangle is going to be 5 units. I say units because I didn't give it centimeters or anything. And this part of the triangle is going to be 4 units. Now, the reason I know they're that long is because our x-coordinate was 5. So from the origin to this point here, we know it's going to be 5 long. Same with our y was 4. I know from the origin up to here is going to be 4 long. So I was able to figure out 2 of the measurements on the triangle. So I have 5 units and 4 units. Now I'm looking for this acute angle here. Does anyone know what trig ratio I'm going to use? Can't use any of them. I got to use one specific one. Let's recap. If this is the angle, I have the measurement of what side of the triangle would this be considered? Adjacent, and this would be considered the... So I have opposite and I have the adjacent. Which of the ratios would I use? Tangent. That's right. Tangent deals with, and we'll call it our x. Tangent is our opposite over adjacent. Okay? So remember, I have the measurement of the adjacent side and the opposite side, and I'm looking for that angle. Here's our opposite, adjacent, and this is the angle I'm looking for. So I'm going to plug my numbers in. Tangent x is equal to, our opposite side was 4 units, and our adjacent side was 5 units. So we have 4 over 5. 10x is equal to 0.8. Okay? And now remember, I'm looking for x itself, which is our angle. So that means I need to move tangent to the other side. And when tangent moves to the other side, it becomes tangent to the exponent of -1. We plug 0.8 into that equation. So we take up the calculator. 0.8 And I'm looking for tangent to -1, so I have to hit shift. 38.65. So the angle we were looking for was 38.65 degrees. Okay, for our next question, we have coordinate -6 and +3. And I want you to solve the angle this creates. So first we got to figure out what kind of angle it creates. So I'm going to plot this point on the graph. If you guys look, my x value is -6. My y value is +3. So I go to -6 and +3. Here's my coordinate. I have my 1 point. Now we're going to make a right angle triangle from this also. Now when we're doing this, again, we go from the origin. We already established that, to the point. So I start at the origin, which is 0 and 0, and I connect it to this point. Now I need to make a right angle triangle. So in order to do that, I'm going to be drawing a line straight down again. Okay? So I've now created a right angle triangle. I need to figure out some of the measurements. Okay? Now, with the right angle triangle, I'm going to be looking for this angle here. Again, it's an acute angle in this instance. Can anyone tell me any of the measurements of this triangle? What would the bottom, the part touching the x-axis, how long would that be? 6 units. And how did you know that? That's right. So, because our x value is -6, from the origin to here, we know 6 units long. That's this part. And how about this side of the triangle? 3 units. Good. We know that our y value is 3, so from the origin up to here is 3 units long. So we figured out 2 parts of the triangle. I'm looking for this angle again. Which ratio could I use to solve that angle? Tangent. Same idea again. I don't have the measurement of the hypotenuse. Okay? So, let's say we have, this is our adjacent, and this is our opposite side. Let's scroll down. Set up our tangent. Tangent x is equal to opposite over adjacent. Our opposite side is 3 units, and our adjacent side is 6. Opposite was 3, adjacent was 6. If I go down to solve that, 3 divided by 6 is 0.5. I got to move tangent to the other side again because I'm solving for the angle itself. So when I move tangent, I get x is equal to 0. Whoa, that's not right. X is equal to tangent to exponent -1, and we plug 0.5 into that. So we take out our calculator. 0.5 to tangent -1. I'm going to get, oh, I lost that number. What was it? 26.5. X is equal to 26.5. Okay? So we set up our tangent ratio. We figured out that this angle here is going to be 26.5. So we know that angle is 26.5. The only thing is, when I set up this coordinate, what I'm actually looking for is this angle here. Okay? So I'm looking for the larger angle here. How would I solve for this angle here now that I have this measurement? What would I do? Subtract from 180. That's right. So I take that amount, 180 degrees, because this makes a supplementary angle, and we subtract 26.5. So our angle, we're going to call it angle Y in this case, okay? So I'm going to set that up. We'll call this angle Y. Okay, so we're looking for Y. 180 subtract 26.5. So, actually I better do it the right way. 180 subtract 26.5. 153.5. 153.5. So this angle here, our green angle, is 153.5 degrees. Now, Matthew brought up a very good point. If you look here, technically this is -6 from the origin. Okay? So because that's -6, I'm going to do this in red over on the side here. When we set up that tangent ratio, Matthew's right. I should have had 3 and -6. Thank you, sir. The reason I set it up this way is I want you guys to realize that this distance is just 6 units. So I could have been working in positive numbers. Okay? That would have been fine if I was working in positive numbers. If it was negative, and we'd plugged it in, we would have ended up with tangent to the x -0.5. Now I want you guys to remember what's positive in this quadrant and what is negative in the second quadrant. If tangent is negative, we know that that supplementary angle in the second quadrant is always going to be negative. So it'd be like applying a second negative to this. We'd have to have a negative on the outside. I figure it'll be easier if you guys just recognize the distance. Instead of using the actual value of -6, I want you guys to just recognize the distance in that triangle and get the unit value. It doesn't matter that we're going to the left or going to the right. I want the absolute value of that unit. So it's 6 units long. So we're always going to try to work with positive numbers. It'll be easy for us to do that.